Hello Altair team, I am Lohika from EEE Department at BV Raju Institute of Technology, Narsapur. This video presents my project Smart MPPT Maximum Power Point Tracking System using dual solar panel and load switching. The Altair products I have used to model and test logic-based MPPT control is that slider to set manual irradiance of panel 1, sine wave generator to simulate sunlight variation of panel B, constant blocks to define open circuit voltage, threshold values and initial values, gain to scale the irradiance or step changes like 0.01, multiplier blocks to multiply two inputs to produce an output, unit delay which stores the previous power value, summing junction which adds two inputs to produce an output, sine block to detect whether to increase or decrease the delta P, that is power value, RS flip-flop to decide whether to raise or lower the duty, comparator block to check if duty is greater than or less than 0.5, OR gate to activate load if either panel qualifies, LED to show whether the load is on or off, display to display the output value, scope or plot for graphical representation of power, duty cycle and load behavior over time. Parameters improved. The system model with two solar panels. Panel 1 with manual irradiance as input, panel 2 with automatic sign-based irradiance. What actually irradiance factor mean is that measure of solar power received per unit area. The control logic uses real-time delta P tracking to adjust the duty cycle. The load is turned on only when duty exceeds 0.5, ensures efficient power use. The quantified impact 13.53 watt power is of panel 1, 13.41 watt power is of panel 2. Duty cycle is same for both the panels, that is 0.51. Load is on only when duty threshold is met, avoiding energy wastage. The graphical representation of power versus time. Red line indicates panel 1 and blue line indicates panel 2. For panel 1, the power is almost constant because of manual irradiance. And for panel 2, it is a sine wave because of the automatic irradiance by using the sine wave generator which continuously changes with the time. If we come for the duty cycle versus time graph, red line indicates panel 1 and blue line indicates panel 2 duty. Because of the manual irradiance, similarly as the power, duty is also constant for panel 1. And for panel 2, it is a small sort of square waves because of automatic irradiance. If we come for the load versus time graph, load is almost constant because load is a binary function, either on or off. That is for on 1 and off 0. As load is in on state, so the graph is constant at 1. This project helped me understand how smart MPPT control can be built using logic blocks. I have also learned how to simulate panel output current, track power changes using unit delay and adder blocks, apply RS flip-flop logic to understand duty cycle, control load with comparator and logic blocks, uses plots display to monitor performance. Thank you Altair team for this opportunity. This hands-on experience taught me how to model and prototype without any hardware components.